Hello all, in this video we will solve a numerical using FCFS CPU scheduling algorithm. FCFS stands for first come first serve. So we want to calculate average waiting time using FCFS CPU scheduling algorithm for the following snapshot of the system. Okay. Now in FCFS CPU scheduling algorithm we make use of a queue which is a FIFO queue, that is first in first out queue, right? We are given five processes A, B, C, D, E, okay, and the order of execution of these processes will be shown through a chart called as Gantt chart. Okay, so here I will draw the Gantt chart for you. Now at time zero there is only one process in the picture, and that is process D. So process D would be into the queue at time 0. Now there are no other processes in the picture at time 0. So naturally, no matter what algorithm you use, the CPU will be given to process D. So process D will start its execution. Now we know that FCFS is non-preemptive CPU scheduling algorithm. It means that once a process gets the CPU, it will keep on using it until it wants. Now you can see that process D want to use CPU for 4 time units. So it will keep on using CPU until it wants. So it will use the CPU till time unit 4. But what happens is at time unit 2, a new process arrives in the system, which is process A. But process A will not disturb the currently running process, rather it will come and sit quietly into the queue. Similarly, at time unit 3, another process E enters into the system. Process E will not also disturb currently executing process D because the algorithm is non-preemptive. Process E will come and sit simply into the queue, which is a first in first out queue. Now once D finishes its execution at time unit 4, we realize that at time unit 4 another process enters the system, which is process C. So process C will be entered into the queue. Once D finishes, we look at the queue. The queue is first in first out. Out of A, E, C, A came first. So now CPU will be given to process A. So A will start using the CPU. A will keep on using the CPU until it wants. So A wants to use it for 6 time units. So 4 to 10. So that is 6 time units. A will use the CPU. Okay. But what happens is at time interval 5, another process B enters into the system, and that process would also quietly sit into the queue without disturbing currently running process A. Okay. Then there are no more arrivals. After process B, there are no more arrivals, so life becomes simple. So now we can simply allocate CPU to E. E want to use it for 5 time units, so 10 to 15, so that is 5 time units. Then C will start using the CPU, right? C want to use CPU for 7 time units, so 15 to 22, that is 7 time units. And finally B gets CPU and B want to use it for 2 time units, so that is up to 24. Okay, the typical way in which you can cross verify your answer, which is most often will be the case, that the final time value which you get over here 24 will match with the sum of all these CPU burst times. So if you sum all these values, it happens to be 24, right? 6 plus 2 plus 7 plus 4 plus 5 is 24. Now let's calculate the waiting time. Let's calculate the waiting time for all processes. So let's calculate the wait time for process A. Process A came at time 2 and got CPU at time 4 and then it finished. So from time unit 2 to time unit 4 it was waiting. So the total wait time for process A is 2. Process B came at time 5, got CPU at time 22. So from 5 to 22 the process was waiting. So that wait time happens to be 17, right? Process C came at time unit 4 and got CPU at time unit 15. So from 4 to 15 it was waiting, so that is 11, right? 4 to 15, the difference is 11. Process D came at time unit 0 and got CPU also at time unit 0 and then it finished, so its wait time was 0. And finally process E came at time 3, got CPU at time 10, so 3 to 10 it was waiting, so that is 7. When we add these values together it would be 37, right? Yeah, 37. So what would be the average waiting time? This is the total wait time, 37, divided by number of processes. So when you divide it, the average waiting time would be 7.4. Okay, I hope you have understood this. Thank you.